Welcome to the solutions to the Regents Physics Forces as Vectors worksheet, numbers 1 and 2. Let's read number 1. We have a force having a magnitude of 10 newtons, acts at the same point as a second force having a magnitude of 8 newtons. The directions of these forces can be changed at will. A, when will these forces produce their largest resultant, and what will it be? And B, when will these forces produce their smallest resultant, and what will it be? Let's start with A. This question, when will these forces produce their largest resultant, and what will it be, should sound familiar to you. And these will produce their largest resultant when they're orientated at 0 degrees to each other. That's when the maximum resultant is always produced by any two vectors. So if this is the point on which the forces are acting, and we have one force of 10 newtons acting on that point, and we have a second force of 8 newtons acting on that point, then the resultant would of course be 18 newtons also acting on that point. That would be the largest resultant you could get from 10 and 8. For B, when will these forces produce their smallest resultant? That should also sound familiar to you. The smallest resultant of any two vectors is always when they're orientated at 180 degrees to each other. So if we take a look at this, and we draw this point is the point where the forces are acting. If we let our 10 Newton force point to the right, then 180 degrees to that would be our 8 Newton force pointing to the left. Well, the resultant of those two forces would produce a minimum value of 2 newtons to the right. Okay? So just some review there on maximum and minimum resultants, specifically though this time with forces. All right, let's take a look at number 2. A force of 30 newtons and a force of 40 newtons are applied at the same point on a box. What is the resultant of these two forces when the angle between the forces is 0 degrees, 90 degrees, and 180? All right, let's start with A. Here's the box. And we have two forces. One is 30 and one is 40. 30 newtons, 40 newtons, acting at 0 degrees to each other. So as a resultant of these two forces, clearly all we do is add them. So we would say that the net force, which is another term for the resultant force, would be 30 plus 40, which is 70 newtons. Okay? B, what if these two forces are at 90 degrees to each other? Let's draw our box. Pick one, 30 newtons, and pick another 40 newtons, but make sure the two of them are at 90 degrees to each other. What you can see here is what we talked about earlier with regards to drawing the parallelogram and the parallelogram method of solving for the resultant here. The resultant would be, of course, the diagonal of that parallelogram, and represents, of course, the net force. So how do we find that? We would find that by using Pythagorean theorem. So F net squared equals 30 newtons squared plus 40 newtons squared So when we go ahead and solve for net force, we get 50 newtons. We also, though, need to indicate the direction of that resultant force, and we would do that by finding that angle theta. What trig function relates the 30 newtons and the 40 newtons along with the angle? And that trig function, of course, is tangent. And you will remember that we will take the inverse tangent of the opposite component, which in this case is the 40 newtons, over the adjacent component of 30 newtons. We take the inverse tangent of 40 divided by 30. And I believe we would get, let's look real quick here. I believe we would get on that 53 degrees. We can leave it like that as long as our diagram is orientated to the x-axis like that. Okay? All right, our last question is an easy one as well. Now our two forces have to be at 180 degrees to each other. So we'll draw our box, our 30 Newton force to the right, and our 40 Newton force to the left. And so the net force would simply be 30 newtons minus 40 newtons. So to the right is positive, to the left is negative in this particular diagram. This would give us, of course, negative 10 newtons, just meaning that it's in the direction of the 40 Newton force. Okay? All right, so some problems to simply review. Forces and vectors acting at the angles of 0 degrees, 180 degrees, and 90 degrees to each other. More on forces and vectors in class tomorrow.